How does a black hole give off light? A black hole itself does not give off any light. That is why it is called black. However, matter that is near a black hole can give off light in response to the black hole's gravity. A black hole is a region of space where gravity is so strong that nothing can escape, not even light. It might be surprising to you to hear that gravity can affect light even though light has no mass. If gravity obeyed Newton's law of universal gravitation, then gravity would indeed have no effect on light. However, gravity obeys a more modern set of laws known as Einstein's general theory of relativity. According to general relativity, gravity is actually caused by a curving of space and time. Since light travels in a straight line through straight spacetime, the curving of spacetime causes light to follow a curved path. The gravitational curvature of light's path is a weak enough effect that we don't notice it much on Earth. However, when gravity is very strong, the bending of light's path becomes significant. A black hole is a region where spacetime is so curved that every possible path which light could take eventually curves and leads back inside the black hole. As a result, once a ray of light enters a black hole, it can never exit. For this reason, a black hole is truly black and never emits light. However, this restriction only applies to points inside the black hole. Light that is near a black hole, but not actually inside it, can certainly escape away to the rest of the universe. This effect is in fact what enables us to indirectly see black holes. For instance, there is a supermassive black hole at the center of our galaxy. If you point a high-power telescope exactly at the center of our galaxy and zoom way in, you don't see anything. A black hole by itself is truly black. However, the black hole's gravity is so strong that it causes several nearby stars to orbit the black hole. Since these stars are actually outside of the black hole, the light from these stars can reach Earth just fine. When scientists pointed a high-power telescope at the center of our galaxy for several years, what they saw was several bright stars orbiting around the same blank spot. This result indicated that the spot is the location of a supermassive black hole. As another example, a large cloud of gas and dust can fall towards a black hole. In the absence of friction, the black hole's gravity would simply cause the gas particles to orbit the black hole rather than fall in, similar to how stars orbit a black hole, i.e., black holes don't suck. However, the gas particles constantly smash into each other, thereby converting some of their kinetic energy into heat. With the loss of kinetic energy, the gas particles fall closer to the black hole. In this way, friction causes a large gas cloud to swirl toward a black hole and heat up along the way. Eventually, the cloud of gas falls into the black hole and becomes part of it. However, before the gas actually enters the black hole, it heats up enough to begin glowing, just like how a toaster element glows when it heats up. The light that is emitted consists mostly of X-rays but can also include visible light. Since this light is emitted by the gas before the gas enters the black hole, the light can escape away to the rest of the universe. In this way, light can be emitted from a glowing gas cloud just outside of a black hole even though the black hole itself emits no light. Therefore, we can indirectly see a black hole by seeing the glowing gas cloud that surrounds it. This gas cloud is called an accretion disk. When atoms of gas become hot enough, the atom's electrons are ripped off, causing the atoms to become ions. A cloud of gas that is mostly ionized is called a plasma. The situation gets even more interesting. As the plasma cloud gets pulled ever closer to the black hole, the plasma gets moving faster and faster. At the same time, there is less and less room for all of this plasma. As a result of this high speed and this crowding effect, some of the plasma ricochets far away from the black hole. In this way, two giant jets of glowing plasma are formed, which are called astrophysical jets. The jets shoot plasma far away from the black hole, never to return. Again, this is possible because the plasma in the jets was never actually inside the black hole. When such jets are created by supermassive black holes, they can stretch out for hundreds of thousands of light years. For instance, the image below shows a photograph of galaxy M87 captured by the Hubble Space Telescope. The bright yellow spot in the upper left of the image is the central region of the galaxy, and the violet line is the glowing astrophysical jet created by the supermassive black hole at the center of the galaxy. In summary, a black hole itself cannot emit light, but its intense gravity can create accretion disks and astrophysical jets outside the black hole which emit light. For more video like this visit and subscribe our Knowledge Hub.